Within today's lesson, we're going to be talking more about percent error and error intervals. So we're going to solve more problems about some percent error. So to start off, just to kind of give you an idea and to help you understand the lesson, we're going to go over a lot of iron ore, which is a warm-up that can be found on page 91. This is activity 15.1. It would be in your best interest to follow along with me as I go over the question, as this will help you with your activity 2 that you are going to complete. So our problem is an industrial scale is guaranteed by the manufacturer to have a percent error of no more than 1%. Remember, we talked about percent error yesterday. This is the amount off that one can be, marked as a percentage of no more than 1%. So what is the possible reading on a scale if you put 500 kilograms of iron ore on it? Well, let's figure out what is that percent error. So we know that 500 is my OG amount. That was my original amount that I had, is that 500, meaning that it is 100%. So I know my percent error in this case. I don't have to work out what the percentage is. They tell me my percent error. In this case, my percent error is 1%. Okay, so now I have my proportion set up and I can go ahead and solve it. 500 divided by 100 is 5. And I'm going to do 5 times 1, which is 5. That means that my error can be 5 off. So what this means is that since it is a percent error, it's the amount that is wrong, what it is wrong by. So in this case, my reading can be wrong by 5. With percent error, it's important to note that it can come in intervals. With this means that even though it's 500 kilograms, 1% can either be 5 more than 500, or it can be 5 less than 500. Either way, it is 1% off, whether it's under the amount or over the amount. This means that on the scale, it can measure anything between 500 minus 5, which is 495, to 505, which is 5 plus 500, and still be correct because it's within that 1% error. With the problem that you are going to solve, you will see something similar. In the problem you are going to solve about a sawmill, they are cutting boards that are 16 feet long. Anything that is 1.5% or more is thrown away. So remember, though, that error can be added on to the 16 feet or taken away from the 16 feet as well. So I want to know, first of all, what is that 1.5%? What is the most a mill can take off or add on to the board and still be correct? Then the next problem, knowing what you can take off or can add on, I want you to list me, whether by drawing or typing, 3 lengths that would be accepted. Don't put 16 feet. Put something besides 16 feet. So for example, if you find out that 1.5% is 3, which it's not, But let's say it is. Let's say you find out 1.5% is 3 feet. You could put 17 feet, 17 and a half feet, and 18 feet, because all three of those lengths are within that 3 feet. You could also put 15 feet, 14 feet, or even 13 and 75/100 feet, so 13.75 feet, because all of those are 3 less than 16 as well. The other thing I want you to place in here is on number 2, why would these numbers be accepted? And very similar to that problem, you are also going to give me 3 lengths that would be rejected, 3 lengths that wouldn't work. So again, if we figured out that 1.5% is 3 lengths that could be 3 lengths that could be rejected are 20, 21, 19 and a half, because all of those are more than 3 feet longer. You could also reject ones that are more than 3 feet less, such as 10 feet, 11 and a half feet, and even 12.9 feet, because all of those are more than 3 feet less.